Okay, so fourth video, I lied. So I'm gonna make fourth video preparing solutions. Now keep in mind precision calculation only. Okay, both from solid and by dilution. So the beautiful thing about this is Miss Aragona has already made a video somewhat about it. So if you go to the blackboard, I'm so excited. If you go to Blackboard and you go here, okay, this is one that talks about the 1.3.3 handout. And if you click on this, this will take you to a screencast that Miss Aragona made a few years back about about how to fill this handout. I would suggest you look at from 3 minutes and 8 seconds onward. She would explain task 3 about these barrettes, and down here it actually talks about how do you prepare a solution. Okay, so in this case, I'll let you look at that part. So it's at um, three 3 minutes and 8 second onward where she will talk about this part. Okay, now in terms of the solution part, making standard solution. Now, if you look back at the blackboard, we did this activity, preparing standard and diluted solution, where you have different house colors. Not this one. No, yeah. Where I kind of assigned you guys in different house and you do your calculations, blah, blah, blah. Now, this part is not hard because really it's just what you talk about here. Now, in terms of doing this part, I remember going through this class with you guys before. Um, so let me just draw here. So this is the standard solution. That's volumetric class, if you want to call it that. Okay, I'm a science teacher, not an art teacher. So what you do? So you prepared a standard solution of 0.5 mole per decimeter cube. Now, if you follow this here, this is as I told you on the day of, this is what we call serial dilution. So you end up having preparing 3 other flasks. So you have 0.200 mole per decimeter cube. This one is 0.100 mole decimeter cube. And this one is half that, so 0.05 mole per decimeter cube. So in this case, what you do is this. So you want to have 100 mils of that. Okay, fair enough. So now you want to take some of this standard solution of 0.5. You want to make it 100 mils of this. So you want to figure out how much you're going to be using. Okay, so how much are you going to be using to make 100 mils of 0.2? So this part, you just do C1V1 equals C2V2. Okay, your C1, this is your C1, your V1, how much should you using? Your new concentration, C2 here, and V2, which is here. Okay. Now it's a good practice because this is in decimeter cube. Decimeter cube, you want to change this. I know I put ml, we're in IB, so cm cube. So in this case, convert this to decimeter cube, which is 0.1 decimeter cube. Okay. So in this case here, 0.5, V1, 0.2, 0.1. So in this case, V1 equals 0.2 times 0.1 divided by 0.5. This should be blah blah 0.2 times 0.1 divided by 0.5. That should give me 0.04. Okay, so 0.04 decimeter cube. So I know that I need to use 0.04 decimeter cube. So I use 0.04 decimeter cube of the stock solution in here. And I filled out the rest. So, and then I filled out the rest with distilled water. Okay. So if it is 100 0.1 decimeter cube, so how much water it will be, so it will be this minus this should be 0.06 decimeter cube of water. Okay. Now, in terms of the rest, I kind of said it in class before because you're trying to make solutions using the previously made solution, right? The handout actually said that very clearly. Yeah, using the most recent solution. So what you do is this. You notice that you notice that you're cutting down lowering the concentration by half. So in this case, what you can do is this. You're trying to make 100 mils of solutions. So if you want this to be 100 mils, essentially you use of 100 mils half of it. So half of it will be just water, distilled water. Okay, so you filled out with distilled water. Okay, so you fill out with 50 mils of distilled water, and then you just take 50 mils from here, from the previous solution. So in this case, from the 0.2 mole per decimeter cube, you just take half 50 mils. So you end up just watering it down. You just half of it is water and half of it was 0.2. So your concentration later on will just become 0.1. Okay. And then you do the same thing over here. You top this up to 50 mils of water, and then you top the 50 mils of the previous solution. Okay. 50 mils in here. Okay. 50 mils distilled water. Okay. So this part here, when you know that, oh, you want to make the dilution, it's by half or by a certain ratio, this is what we call by serial dilution. It's a pretty common practice in biology. It's a pretty common practice in chemistry too. So that's why I'm just going over that part. Keep in mind, you just need to know how to do calculations and so forth. No evaluation here. Okay. So